Hydrogen is the most abundant in the universe. Nearly 70% of the total mass of the universe is hydrogen. Valency and oxidation state. Hydrogen has an oxidation state of +1 in most of the compounds, just like alkali metals. There are 3 isotopes of hydrogen, that is protium, deuterium and tritium. Tritium is widely used as tracer in both industry and research. A tracer is a radioactive isotope whose presence in a system can easily be detected. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today we are starting up a new chapter, Unit 9, that is Hydrogen. We'll see now the exam corner. The number of hours required to do this chapter is 4 hours. In this question paper pattern, and in the part C, that is 3-mark question, the question number 24 will be having from this chapter. The total marks allotted for this chapter is 3. What are the contents we are seeing today is occurrence in nature, position of hydrogen in the periodic table, resemblance of hydrogen with alkali metals, resemblance of hydrogen with halogen family, and dihydrogen, about dihydrogen and the preparation of dihydrogen we'll see in this session. First, occurrence in nature of hydrogen. Hydrogen occurs throughout the universe. Mainly it occurs in empty space between stars. Between stars it will be available. Hydrogen is the most abundant in the universe. Nearly 70% of the total mass of the universe is hydrogen. The occurrence is between the stars it will be present, and 70% of the universe contains hydrogen. Hydrogen occurs on the earth primarily in the form of water. Individual hydrogen you cannot see on the earth. So, it will be available in the form of water, that is H2O. Every molecule of water, H2O, contains 2 hydrogen atoms and 1 oxygen atom. That we know already. Hydrogen is also found mainly in rocks and minerals. Its abundance is estimated to about 1500 parts per million, which makes hydrogen the 10th most abundant in the Earth's crust. The planet Jupiter and the Saturn contains high number of hydrogen gas. So once again, between the stars hydrogen is present, not only in between the stars, within inside the earth in the form of water, that is H2O, and it is present in rocks and minerals also, and it will be considered as 10th element most abundant in the earth, as well as it is present mostly in Jupiter and Saturn planets also. See here, this is hydrogen, its atomic number is 1 and its mass number is 1.008 and its symbol is capital H. Next, position of the hydrogen in the periodic table. The properties of hydrogen is similar to the both alkali metals and halogens, but hydrogen atom lose electron and becomes H+. Why it is resembling, or what are the similar properties of hydrogen with alkali metals and halogens, we'll see in the next coming slides. But the property of hydrogen will resembles to the alkali metals properties and as well as the halogen properties. But hydrogen atom lose its electron easily and it becomes H+. Whenever the electron will be lost, it will become the cation. It has 1.5 into 10 to the power of -3 picometer size. Because of very small size, it does not exist but always associated with other atoms or molecules. Due to its small size, it will not exist as an individual atom or molecule. So what will happen? It will be combined with another atoms as a molecule. Due to its unique behavior, it is placed separately as the first element in the periodic table. Its hydrogen properties resembles to the alkali metals as well as halogens properties. It has not given the unique, it has not given the perfect position like other elements. So what they have done? It is placed separately on the top of the periodic table as a first element. Next, resemblance of hydrogen with alkali metals. How the hydrogen will be resembled with the alkali metals, we will see its properties. First, electronic configuration. Hydrogen has 1 electron in its valence shell. So its electronic configuration is 1s1, same as in alkali metals. Usually in the alkali metals, the first group alkali metals will be having valence shell S1 only. So here is also valence shell S1 only. Next, electropositive nature. Just like alkali metals, hydrogen has a tendency to lose electron, okay, and form cations. It will form cations easily. Valency and oxidation state. Hydrogen has an oxidation state of +1 in most of the compound, just like alkali metals. It is also having oxidation state of +1. And combination with electronegative elements or non-metals, like alkali metals, hydrogen combines with easily with electronegative elements like halogen, oxygen, sulfur to form halides, oxides and sulfides respectively. Due to its electropositive nature, it tends to combine with electronegative elements easily to form oxides or halides, etc. Next, resemblance of hydrogen. Next is reducing nature. Like alkali metals, hydrogen is also a good reducing agent. What is the good reducing agent means? It gives electrons to the electron recipient or electron deficient species. Next, liberation at cathode. Like alkali metals, hydrogen is liberated at cathode on subjecting to aqueous solution of its compounds with electronegative elements to electrolysis. Like alkali metals, electrolysis has been done. This hydrogen will be liberated at cathode side. See here HCl, H2 as at cathode, Cl2 is in anode. In NaCl, see here, like alkali metal, Na is at cathode, Cl is at anode. So resemblance here, both alkali metal and hydrogen takes place at cathode only. Next, resemblance of hydrogen with halogen family, which is most electronegative family. Electronic configuration, like halogen, hydrogen requires one electron to achieve the electronic configuration of noble gases. Hydrogen also needs its one electron to achieve noble configuration, octet noble configuration, like halogen also. See here, it also needs one electron to fill its valence shell. This halogen group also needs one electron to fill its valence shell. Next, electronegative nature. Just like halogen, hydrogen has a tendency to accept one electron and form H- ion also. It is having the capacity to accept also like halogens. After having what will form H- ion. Ionization enthalpy. The ionization enthalpy of a hydrogen is quite closer to halogens but much higher as compared to alkali metals. Ionization enthalpy is like similar to halogens but higher than the alkali metals. Combination with metals and non-metals, like halogen, hydrogen combines with metals to form salt. Usually hydrogen with metals or non-metals will combine easily to form a salt. This is atomicity and non-metallic characters. Hydrogen exists as a diatomic molecule like halogens. Usually will not tell like H only, it will be considered as H2 like F2Cl2 or Br2I2. Next, liberation at anode. Like halogen, hydrogen is liberated at anode on subjecting to the aqueous solution of its compounds to electrolysis also. Whenever the electrolysis of some compound has been done in the molten state, there is a chance of the hydrogen liberated at anode also like halogen. This is another concept. When the electrolysis has been done at the molten stage, H2 will be presented at anode. Next one, resemblance of hydrogen with carbon family. There is a resemblance of hydrogen with carbon family also. We'll see. Valence shell of hydrogen is half filled like elements of group 14. Its valence shell 1s1, right? That's why. Carbon 6, 1s2, 2s2, 2p2. Okay. Ionization energy and electron affinity of hydrogen and carbon are comparable. Electronegativity of hydrogen and carbon family are almost similar, that is H is having electronegativity of 2.1 and C is having 2.5. Similar electronegativities range. Next is dihydrogen, that will be considered as H2. First we will see isotopes of hydrogen. There are three isotopes of hydrogen, that is protium, deuterium and tritium. We will see first one, protium. Its atomic number and mass number is both one only. Hydrogen, one is sometimes called as protium. It is the simplest and the most common form of hydrogen. Ordinarily, hydrogen is known as protium only. It has one electron, one proton, but it has no neutron only. Its mass number 1.0081, percentage in natural hydrogen 99.98%, because it's a common kind of hydrogen. Next, deuterium. Atomic number is 1, mass number is 2. It has one electron, one proton and one neutron. Mass number 2.014, percentage in nitrogen very less, that is 0.0156%. Uses of deuterium. Deuterium oxide or heavy water is used as moderator in nuclear reactors to slow down the neutrons. In the nuclear reactors, there is this neutrons will be carried down. To slow down that neutrons, this deuterium will be used as a moderator. And tritium, its atomic number is 1, mass is 3. The third isotope of hydrogen is called tritium. It has one electron, one proton and two neutron. Mass number 3.017. Percentage of natural hydrogen 1 into 10 to the power of minus 15%, very less. What are the properties? This is radioactive isotope, so very less. It decays to emit low energy called beta particles from the tritium. Beta particles can be emitted. It has half-life of 12.5 years. This isotope is unstable and it is present in very less traces. These are the properties of the isotopes of hydrogen. Next, uses of hydrogen isotope, that is tritium. Tritium is readily produced in nuclear reactors as a traces very little bit. Tritium is widely used as tracer in both industry and research. A tracer is a radioactive isotope whose presence in a system can easily be detected. It will be very minute particles and it is used as a tracer in research and industries to identify the other elements which is having the radioactive properties. Tritium is also used in the manufacture of fusion bombs also. Okay, these are the uses of tritium. Next, preparation of dihydrogen. Laboratory method of preparation of dihydrogen. There are various kinds of preparation. Hydrogen is prepared in the laboratory in small scale by the reaction of very reactive metals like zinc with dilute hydrochloric acid. See here, zinc plus hydrochloric acid. Salt will be prepared like ZnCl2 plus hydrogen gas. Hydrogen can also be prepared by the reaction of zinc with aqueous NaCl. Zinc plus NaOH, that is sodium hydroxide. It will form sodium zincate and hydrogen gas. We have to observe that hydrogen gas in which all reactions it will be liberated. Next, commercial production of dihydrogen. Commercially, hydrogen gas is obtained by the electrolysis of acidified water using platinum electrode. Usually the commercially hydrogen or dihydrogen can be prepared or manufactured. See, in the water electrolysis, if we do H2 gas plus half O2, that is H2 gas is main for now in the preparation. By the electrolysis of water, it will be formed. Next is high purity dihydrogen gas is obtained by electrolyzing warm aqueous barium hydroxide solution between nickel electrodes. By using nickel electrodes, high purity dihydrogen gas will be obtained in the electrolysis using barium hydroxide. Dihydrogen gas is also obtained as byproduct during the manufacture of sodium hydroxide, okay, and chlorine by the electrolysis of brine solution. Here also in the brine, when the preparation of brine solution, hydrogen gas will be liberated, that can also used. The cell reactions during electrolysis, see at the anode, chlorine, it will gain the electrons. At cathode, water will be given out like Cl and here H2, OH minus. The overall reaction Na plus Cl 2H2O gives to Cl2H2 plus 2 Na, that is sodium, and 2 OH minus. Okay, these are the overall reaction. Next, dihydrogen is obtained by the reaction of steam with hydrocarbons or coke at high temperatures. When the reaction of steam with the dihydrocarbons or coke at high temperature will be given, that time also hydrogen will be liberated. This is hydrocarbon, we know. See here, methane when treated with water at the temperature of 1270 Kelvin, nickel, carbon monoxide plus H2 will be liberated. The mixture of CO and H2 is called water gas. The mixture of CO, that is carbon monoxide, and H2 is used for the synthesis of methanol and a number of hydrocarbons. So this mixture is also called as synthesis gas or syngas. Nowadays, syngas is produced from the sewage, sawdust, scrap wood, newspapers, etc. The process of producing syngas is called syngas from coal is called coal gasification. See, carbon plus water, carbon monoxide and hydrogen gas will be liberated. From the various methods or from various waste or sewage, the hydrogen gas will be liberated nowadays. So, it will be called it as syngas. The production of hydrogen can be increased by reacting carbon monoxide of syngas mixtures with steam in the presence of iron chromate as catalyst. This is called water gas shift reaction. So, carbon monoxide plus water, what will happen? Carbon dioxide will form and also hydrogen gas will be liberated. That will be called as water gas shift reaction. Carbon dioxide is removed by scrubbing with sodium arsenate solution. Presently 77% of the industrial dihydrogen is produced from petrochemicals, 18% from coal, 4% from electrolysis of aqueous solutions and 1% from the other sources. Hydrogen gas can be liberated in the so many various kinds. These are the different kinds or different from the materials, different materials they are going to produce the hydrogen gas. So this is about the preparation of dihydrogen by using different kinds of methods. In the next class, we'll see the physical properties, the chemical properties and the uses of dihydrogen, and we'll see the hydrates with its forms. I hope you have understood whatever I have taught today. So we'll meet in the next session. Thank you.